Anyone can hear me? Hello?
Yes, we can.
Yeah, Prof, we can hear you.
All right, so I think one of you's actually emailed me about the missing homework, and so I'm gonna send you the homework for that for sure. For those of you who can sort of feel like submit it a little bit late, but again, chapter 1 and 2. I even post chapter 2 summary in advance, and pretty much I also upload the homework assignments for the next one, so we can check them. Is the due date will be 2 weeks after after I post it. So it should be due next Monday for 1.3, 1.4, 1.5, 1.6, and 1.7. Okay. Try to do as many problems you think as you can before we actually move up to the next chapter. So the first chapter, of course, is going to be relatively important. So just try it out with all of these questions, with the lecture notes, with class notes, and all of that, and you should be okay on the exam. All right. And I think that we're going to have the further exams after we finish the first 2 chapters. So I actually posted in advance just in case that we have anything like that. So since I'm using the personal computer, so it might be a little bit sidetracked for a little noises and also a little content that we have here. Okay, so we are actually, I think the lecture note was posted up to date. So let's say this is the last thing that we did, and we're trying to learn how to solve, how to find and solve the composite functions, and it's definitely going to be on the exam for sure. Okay, so and by the times we going, yes, questions. And by the times,
my question is, what time does the class start?
The class start at 10.
Oh, okay, because I was confused because I thought you started earlier. Because
yeah, I start since I end the class a little earlier. So I just want to give people some, some information that we need to know last week and for the upcoming weeks. Of course, I'm going to repeat it, and it's basically on the recording. So the class, I'm a little early. Come on, so so that happens. Okay, so. And now we're going to go back to the course content. So this is the first chapter that we have to deal with. And I believe the note was clear enough. And this is all we need to focus on for certain terms. Okay. And now we're going to deal with the new chapters. Okay, we're gonna do, so let me just review a certain like composite functions and see how it looks like. Okay, let me just take a look at the question that we did earlier, question number 3. So this is the problem that we haven't touched, and so let me just copy and paste for that real quick for this for the question. Okay, and remember that we're not gonna do out of, so we did question number 4 last time, but I know it's not very clear, and especially when it comes to the terms that we have to deal with the values of the functions. Okay, all right, so this is what the problem looks like. We're going to have the f of x equal to 1/3x minus 9, and the g of x is x squared minus 1. Okay, correct? And I want to find the composite functions. Hello, Mr. Atido. Everyone to the class. So I want to find the composite functions of f of g of 1 and f of g of 2. Okay, so remember the questions want us to find a specific values of the function, so we're not going to solve for that x first. We try to understand what it means by f of g of 1. So f of g of 1, so let me just do that, rewrite them. So what does that mean by f of g of 1? Anyone still remember? I know it's been a week. Good morning, Erica. It's been a week that we forgot this material, I think, after the long weekends, after the long week. So anyone still remember how we can figure out f of g of 1? Yeah, so g will be the inner functions, and then the outer function is going to be the f. Okay, so very important thing. So I'm going to make the f with different markers, so you can definitely going to see what it means by that. I'm sorry, I make a g with different marker. Okay. All right, so I can rewrite them with f of g of 1, correct? Okay, so this is a thing that we need to try to figure out. We try to find out what it is. Are we good? So in order to make it easier, in order to find the f of g of 1, so it's always good to figure out what is the g of 1. So the g of 1s can be found by plugging in the value of x equal to 1 into the function of g, which is x squared minus 1. So we're going to have 1 squared minus 1, and the answers for that equal to 0, correct? Are we good? Are we good with this?
Yes.
I don't understand it. Like, you got me confused because I thought we need to put the equation inside the equation.
No, we only do that when it comes to f of g of x. So when it comes to that equation, then we're definitely going to put in the g function into the f and so on and so forth. But when it comes to the value, so we definitely not going to do that. I mean, we can solve using that method, but it's a little more complicated, correct? All we need to do first, we just need to plug in the value. So we need to figure out what is the g of 1 first. So we want to solve for g of 1s. And then after that, we're going to use the output of g, and we're going to use the output of g as the input of f. Okay, so we're going to rewrite the entire f functions in terms of f of 0. Does it make sense? Yes.
Not, oh yeah, kind of. Not really, but I'm getting there.
Okay, so it doesn't make sense. So we need to figure out the output for g. So the output for g is the g of 1, right? So the output of g will be the input of f. So what is the input of f? The f is 1 over 3x minus 9. So we have to replace x equal to 0 into a function f of x equal to 1 over 3x minus 9. Are we good? Are we good for that?
Yes.
Come on, you're gonna give me some response to the class. Catter, what do you mean by catter? Is that clear or is that not clear? Or still have some terms that we want to understand? You know, give me some positive feedback. Or maybe trying to tell me it's confusing, then I can go over it one more time. Okay.
Professor, I have a
Yes.
question.
Mm-hmm.
Did you grade the homework one?
I will grade it tonight. Because you know what? Because
Okay.
they're actually a person who missing a few problems. I'm going to send her a copy for that. I checked the email this morning, but I didn't have time to respond. But I would definitely going to let that person finish it, and then I would start grading it. Okay. So if you're missing, yeah. So just remember how I grade a homework. I do not grade all of them. I just grade part of it, right? So I pick 2 or 3 questions to grade, and if you miss the questions that I grade, you're gonna miss the point. Yeah, that's cool, Louis. It's not a big deal. Yeah. So
All right.
yeah. Okay, so and then we're going to get the answers as -1/9 because remember we can't use a calculator on the exams. I can't really stop you from using it, all right? Because this is the hybrid course, and the answers for that is you're gonna plug in 0. You're gonna get the answers, which is -1/9. Are we good? Are we good for that?
Yes.
Yeah.
All right. So now we're gonna
Yeah.
start. I'm sorry. So we're gonna start with another example. So I want, instead of finding the f of g of 1, so I'm going to find g of f of 2. So I skip this guy. So I want to find what is the g of f. So I'm going to do different marker for that. Okay. So the first marker representing the outer function. So I call it, so g will be the outer function, right? So g o f. So the f will be the inner. So you can see that I'm using different markers, so we can definitely check what it is. Oh yeah, so Mr. I think they're actually giving us the final answers, but I need to slow down a little bit. So first, we need to understand what the g of f2 means to us. So we need to figure out the g first, right? So I'm sorry, we need to figure out the f first because that is the inner function. So we're going to rewrite the g, and then as the outer, so the f would be f of 2. Okay, so I'm using different markers, so we can definitely gonna view this and see what it is. Yeah, and so what is the f of 2 in this case? So the f of 2, I want to use different marker to represent the inner function. So the f of 2, we need to plug in when x equal to 2 into the f function. So the f function is 1/3x minus 9, correct? Yes, so f of 2 equal to, no, what is f of 2, which is 0. So so let me just plug that in first. We're going to check the answers for that. So do you remember the f is the inner function? So we need to solve what the value of f looks like. So we're gonna plug in x equal to 2 into 1/3x minus 9. Okay. So the 3 times 2 minus 9 in this case. So the answers for that will be equal to what? Anyone? How the study? I'm sorry.
1/-3.
Yeah, so we can put a negative sign in the front, so that'll be -1/1/3. Okay. How the study group going, organized by Mr. Atindo? Is that going good? Is that going well so far? Any concern, or maybe you're gonna make the group more attractive, or maybe you want me to be the to be there? Yeah.
My concern is, can you hear me? Oh, okay. Oh, my concern is like I don't understand because in the beginning you put 1 minus 1 is 0, and then you put f0, and then you connect it to the 0 to the f equation.
Which one? 1 minus 1 equal to 0. Oh, it was the problem. This was previous problems where I have to find the value for g of 1 because I need to make sure what is the g of 1 looks like, because after that it will be served as the input for f. So in order to look for g of 1, I have to plug in x equal to 1. So let me just do that. X equal to 1 into x squared minus 1. Is that clear? So it went x.
Oh, okay.
Yeah. So we need to understand what is the g function looks like and what is the f function looks like, and then you have to plug in the right value into the right functions. Correct?
Correct.
Yes.
Yeah, got it. Thank you.
Mr. Dindu, so what is the 1/0? So 1/0 is not equal to 0. 1/0 undefined, but 3 times 2 is 6, minus 9 is minus 3. So the answer for that is a -1/3. Okay, and I feel like that's clear to everyone.
Did you say I'm wrong?
Yes. So you have to do like 3 times 2 is 6, minus 9 is minus 3. So that should be -1/3. It's not 0.
3 times 2 is 9. 9 minus 9 is 0.
No, 3 times 2 is 6.
Oh, 3 times 3 is 9. My
Oh,
mistake.
come on, you gotta be kidding me. Okay, that's perfectly cool. It's the morning time. And now we're going to, and also remember, is that window. So you gotta be careful. 1/0 is not 0. It's 1/0 undefined because we cannot do any calculation on a calculator with 1/0. Okay, so remember that we can do
That's
add on.
correct. You have
Yeah.
to be right about that.
And so, and also now we're going to solve for g of f 2. So the g of -1/3. Okay, so we're gonna put down -1/3. Okay, is that good, everyone? So how can we plug in g of -3s right there? Anyone? So we
It's
go
gonna
in
be negative. Is -3 the
Neg-
power minus
uh-huh,
1.
-1s, right? So we're going to replace it with -1/3 raised to the second power correct? And then -1. Are we good?
No, so the 1/3 was added because I don't understand because it's GOF instead
Yeah.
of FOG.
Yes. Instead of that, so we have to be careful. So we have to solve for f2 first, right? So first of all, we have to take care of the inner function. So the inner function. So the inner one is f2. So we have to plug in x equal to 2 into the f of x function. So there'll be 1/3 times 2 minus 9. So we get the answers will be -1/3, right? So after that, we need to figure out the outer function of g. So in this case, so the inner is f2. So that would be serve as the input for g. So what is the g function? The g function is x² - 1, correct? And then all I need to do just plug in -1/3 into the g of x function. So we're going to have -1/3 square minus 1. Yes, and apparently that -1/3, so negative and negative. So we have to be careful. So 1/3 times 1/3 will be 1/9. Okay, so 1/3 times 1/3 is 1/9 because negative times negative become positive. So the whole term right there. So like Mr. Dindo just did earlier. So we're going to have this one equal to 1/9. Are we good? Is that clear? So one
I have a question.
Yes.
I'm so sorry for interrupting you. So you know how they said to find. My question is, did we skip a problem because we went to g times f parentheses 2 instead of f times g parentheses 2?
Yeah, so we skip that first. We skip apogee parentheses 2 for that.
Okay, thank you.
You're very welcome. So I don't have time to do all the questions. I'm so sorry about this. Yeah. And so -1. So what do we get? So 1/9 minus 1. So meaning that I need to subtract the fractions, right? So we're going to say we have to look for the common denominator. So that'll be 9. And then we're going to take 1 minus 9. And we're going to have this guy equal to -a over 9. Are we good? Is that clear to everyone's or?
Yes.
So.
I'm actually understanding now.
Oh, so just a little. So is it the composite function is just basically means that one output of the functions will be served as an input of another function. Okay, so this is what we have for the composite function. So now we're gonna deal with the last two. What is the f of g and what is g of f of x? So remember, if the question does not give us the value, but in fact, it's just giving us the x. The problem turns out to be a little more complicated. Okay, so so we're going to solve for the last two. What is FOG of X? Anyone?
Yes, I know how to find it. So you need to connect x to the second power in -1.
Uh-huh. Why are you guys so good at those things? But it's becoming numbers. I feel like it's a little easier, but you guys just like, you gotta be kidding me. It's like genius, but genius cannot do the easy problem. Come on. So now we can solve, we can do, what is the g of x function? The inner functions is x squared minus 1, correct? Right? The
Yeah.
inner is x squared minus 1. So what is the outer functions here? The outer function is f of x, which is 1 over 3x minus 9, correct? So we have to rewrite the outer function first. So remember the outer function right with the red markers. Okay, I can see through right away. Okay, so I'm going to rewrite with 1 over 3x minus 9, correct? Is that good? Are we good with this? Are we good?
Yes.
Okay. And now I'm going to replace 3 something minus 9.
Question.
I have to replace it by
Question.
g of x function.
Question.
Yes.
Question.
Yeah.
X equals to what? Are you trying to find x, or you
No,
already?
no. The x is a variable. So in this case, the x is not
As a
known.
variable is intentional.
Yeah.
Okay.
Yeah, it's not known. It's just a variable for that. But for the first two examples that we just did, the x equal to 1. Okay, so let's say for the second example, for the g of f2, so the x equal to 2. But in this case, x is just the x by itself, so we don't have to worry about that. Okay, so doing this, I believe, was a little tough for us, but I'm not sure how you guys actually finish it. So I'm going to replace the x by the inner function, so that would be x squared minus 1. Are we good? Is that good, everyone?
Yes.
Professor, we're gonna replace the x for the second value because we now have no number in the x and
Yes. Yeah.
to
So
find
we're going
out.
to, yes. So we're going to use strategy if the questions ask us to look for the composite function of x.
Okay.
Yes, but we can also use this strategy to figure out what is the f of g of 1. I just replace x equal to 1s, and I can solve for that. I get -1 over 9. But I believe doing this a little easy. I'm not sure which way is easier. So I can solve for f of g of 1. I just replace x equal to 1s here, for instance. Okay, for instance, I can replace x equal to 1s, x equal to 1s here. So we have 1 minus 1 is 0, 3 times 0 is 0, so 1 over -9, and we got the answer the same thing. Yeah.
So, Prof, let's finish with what you are doing so that we can follow it, then we can try the other way.
Yes, we can try that away. It's up to you. And so if I want to solve for f of g of 1, what should we do? I'm going to replace the entire f of g of x by x equal to 1. I still get the same answers as -1 over 9. It's not about the strategy. It's just, yeah. So it's just the way that we look at it. I think there are only 2 strategies, and another example was something that we have playing around with the functions. This strategy seems faster. Oh yeah, I get so, but there's no idea, or there's actually something that we might want to deal with. So we need to simplify these functions, correct? So we need to simplify the entire these functions right there. So we're going to put it down as so we're going to rewrite. So this is, so we're going to multiply the terms, 3x squared and -3, correct? So we're going to put it down as 3x squared minus 12. Okay, is that good, everyone?
Yes.
Am I doing too fast for this or?
A little bit, yes. I like your explanation go too fast when you talking. Even if
So,
it's not my point blank, and the term
yeah.
that you use, it's like,
Uh-huh.
please remember?
Right. Come on. This so we're gonna have like 3x squared minus 3, and then this minus 9 is here, and then you're gonna get 1 over 3x squared minus 12.
Okay, let me write it down that part because I don't want to lose nothing. Even though that you recorder, that is still, you know.
Come on. You know what? You know what happened to my student when I teach statistics course? I feel like I got some disconnected from my internet. So you know, I got sidetracked from my boyfriend. Come on, you gotta read my recording. And that's the way it is. Come on. Okay. Anyhow.
Okay, got it, Professor.
Okay. Yes. Questions?
Okay, my question is, you know how we did for the first problem, the one that it says that you need to instig substitute one. So when it says to substitute x, you reduce the inside function to the outside function. Is that
Yeah. So
okay.
Let's say we want to find f of g of 1. I can't just, so what that means, we have to get this one first. Okay, we have to get the g of 1 first. We have to substitute x equal to 1 into the g of x functions, right? And then after that, we got the certain value, and then we substitute that value into the f, and then we're going to get the final answers. Is that clear? I mean, it's just a little way, but yeah, so this is the first thing that we have to deal with, okay? Are we good?
Yeah.
Yes, this chapter was very, very complicated because we had to do with a lot of things. And after this, we're going to deal with what? We're going to deal with the transformation of the function, okay? And so how can we solve a g of f of x? Anyone? Anyone's here? Come on. What is the outer function?
I got it.
You got it. All right.
Yeah. So f is inside g. So
Okay.
that's
Uh-huh.
parentheses open. Parentheses open.
Right. Parentheses. So we're gonna put it down as parentheses, right?
Parentheses open, and then you write what of f, which is a fraction, which is numerator 1 over a denominator 3x minus 9.
That's it. That's pretty much it. And then you don't have to simplify this one because it's just too complicated, okay? So the most important thing that we need to realize is that what is the outer function? The outer function is x squared minus 1, okay? So we're going to write the terms without x, right? So we have... Okay, so I apologize. So there are certain noises that's distracting, so I gotta mute you. And so what that means is that we need to rewrite the term with something squared minus 1. So we have to replace x by the inner function. So what is the inner function? The inner function in this case is the f, right? So the inner functions here is 1 over 3x minus 9, okay? Yes, question, Anna?
I don't have a question.
Oh, you know what? That's fine. That's fine. Maybe your hands get itchy on Zoom, so you might put you have skill for that. Yeah. So we're going to replace this by 1 over 3x over minus 9. So that's going to be the final answers. Are we good? Are we good for that?
Yes, yeah.
So we don't have to simplify it. So if we want to figure out what is g of f of 2, I have to plug in x equal to 2, right? I have to plug in x equal to 2. I got 3 times 2 is 6 minus 9 is negative 1/3, and then square. So that would be 1 over 9 minus 9 minus 1 is negative 8 over 9. So you're going to get the same answers. But it's we don't have to do that, okay? Just leave the answer like this. Any concern? Any question?
So the answer is going to be minus 8 over 9.
No, the answers is here. But when it comes to the previous example, I can actually plug in x equal to 2 into the here, and and solve for that.
You can simplify that, you know, right?
Yeah, we can
It's
simplify
more
that.
complicated.
Yeah,
It
which
will
is a
be
little
like
more complicated. Yes.
9x to
Yeah. All right.
minus AB
Yeah.
minus 2AB. 9x to minus 27x
Okay. All right.
minus 27
What do you mean by no?
minus plus 81. 9x to the second power minus 27x plus 81.
Right. So uh we do not have to simplify that. Yeah, so we can actually rewrite the term as 1/3x minus 9 squared, which
We
is
reverse that part, right, Professor?
yeah.
The second step is to reverse 1/9.
Yeah.
9 parenthesis x minus negative minus 3/2, right?
What do you mean by 3/2 in this case? So we don't
Like never mind.
okay, so if we want to expand the term, which is cool, but you don't have to, okay, just keep the answers because it's just too complicated. You know, come on, when it comes to the complicated question, what should we do? We should have voted. I'm just kidding. You know, you don't have to just leave the answer at that. I'm going to give you full credit. Okay, so we don't have to expand the terms as 1/9x squared minus 54x plus 81s, and then we're going to combine with the 1. It's just complicated. Okay, we're just trying to look it up with a simple way. In math, this might relieve a lot of pressures when we study it. Okay, so are we good? Are we good for that? So this is
Yes, I actually understand it.
Yes.
oh, you actually understand it, but you still don't love
I have
math.
a question.
Yeah.
I have a question.
Yes.
That's the only way we can simplify the answer for the last question.
Which one?
The last one, the one that we did.
Oh,
Okay.
we don't have to simplify it, to be honest. Just
Okay. So that's the answer.
yeah, that's the answers for that.
Thank you. I'm sorry.
That's fair because it's good to know. It's good to ask the questions, and this is the reason why we're here to help and to get it done correct. So if you don't ask questions, how do you know if our answer is correct or not the correct answers, right? So please ask more questions because this is how we're going to get better at math and going to overcome most of the challenging work that we have done so far. Okay, so now we're going to move up to the next topic. Any concern? All right, so there's no concern. I'm going to move up to the next topic. So instead of we dealing with the term, so we're going to deal with the transformation of a function. How many of you heard of that transformation of a function? Transformation. Come on, you heard of the movie Transformer, right? You gotta be kidding me. You haven't watched it before. Oh, come on. All right, so the function transformation is just the same way that we have to transform a function, but one unit to another unit, but it's gonna keep a certain characteristic of it, okay? So I'm going to deal with them. So before and after that, we're gonna go back to the express the function as composite of two functions of that would be more interesting, but we going to come back to this question later on, but transformation is actually very, very important. Okay, so we going to learn the transformations that we have, the vertical shifts and the horizontal shifts. So this is what it looks like. So given by a functions f, right? So what does that mean when you look at this function? Okay, so when the y equal to f of x plus c, So where C is positive. So how can we imagine that function? So let's say we're gonna have the function f of x equal to the square root of x. Have you seen that function before? Okay, so this is what we call the square root of x, right? So what the function looks like, it should be something that we have right there. Okay, so I'm gonna just use a certain marker to draw for the function. Okay, and then this is what the function looks like. Are we good? It's keep going forever. It's starting from zeros here.
I saw that in the textbook. The fx equal to square root of x. That
Yeah.
shape. I
How do we?
in the question too. I saw it in the question asking about
Yeah, I think we.
Yeah,
one of the homework questions actually. So we know the fact that the curve is f of x equal to radical of x. So it's what it looks like is that it's starting from the origin.
Homework question 38. It was annoying to me too.
It's that is not, yeah. So I would consider that I would go over it after I finish grading the homework for you guys. But definitely I'm not gonna pick the hard question to grades. I will pick the question that the majority of you get the right answers on it. Okay. Just don't want to, I'm not going to pick something like really tough and complicated questions to grade on the exam for sure. But we have first curve, which is f of x equal to radical value of x. You're very welcome. Radical value of x, and this is what. So we start from the origin 0. So we have to start from 0. So we know the domain for that will be from 0 to infinity. The range for that will be from 0 to infinity as well. So it's always start from 0. Okay, so this is what the curve looks like for f of x equal to radical value of x. All right, so now I want to shift the curve, right? So this one is shifting the function. So I'm going to take, this is one example, okay? And now this is what I'm going to do with, so example 1a. I want to shift the functions into f of x equal to, what do you think? I'm going to shift the function into radical x plus 1. What do you think? Okay, how the function looks like? It's gonna go up. How many units?
1.
How do you know that?
Because it's plus 1. 1 is the y, I believe.
Okay, yes, that's very good. It's 1 is coming to the y, so meaning that we have to shift up 1 unit. Okay, so now how can we actually draw out the functions by itself? So we're gonna draw the functions with radical x plus 1. But how do you know it's gonna shift up 1 unit, but basically, but not shift to the left?
That's why it was annoying. What you just did, you shifted up by 2. I had to figure that out on my own.
Oh,
it shifted up by 2. Exactly that. Yeah.
Okay.
It wasn't outside the radicand. It was inside. It was x plus 2. Square root of x plus 2. So it shifted left instead of up.
We're going to deal with them, okay, later on. But do we agree that this is gonna shift the function up by 1 unit? Are we good? So we're going to hold the same characteristic of function. Of course, my function doesn't look the same thing, but it's just move up. So you're just shifting the curve, just moving the curve. In other words, I can just copy these pictures. I can just make this move, copy that one. I just make this move up to 1 unit, okay? And that's pretty much a thing. Are we good? Are we good for that?
Yes.
Yes.
Okay,
Yes.
so this is what we shift up 1 unit. So what happened if I have another example? So let's say example 2a, example 1b. So let's say I'm going to get the functions f of x equal to radical x minus 3. What do you think?
So the equation is going to be located, they go down to -3.
Right, so it's going to shift down 3 units. I'm sorry, does it make sense?
Yes, makes sense.
That makes sense, right? And so what it looks like, I'm not gonna draw, can I draw it on the same graph? Do we have to draw another graph for that? Is that cool?
You
I'm
can
gonna,
draw it the same graph. I believe it's going to be make
Different
more
color.
sense.
You could join the
Yeah.
same
Personally.
graph, different color.
okay, thank you so much for that. It's just, I'm really bad at drawing, but you know what? You're gonna help me a lot in this case. So, so this is next. So we're going to ship down. So we start from 0. So we're gonna ship 1, 2, and 3 units right there. So we have, this is -3. And then the curve should be the same, right? The curve should be the same, but it's just shifting down 3 units. So this is what the function looks like. Okay, are we good? Is that cool?
Yeah.
I understand. Thank you.
Yeah,
I understand.
yeah, that looks good.
That looks cool. That's that. I think that is the easiest part that you might have on the exam. But it's still part of it that we need to understand what it is. So now we're going to draw, not we're going to look like another function. So now instead of we changing the y, so we see that the function is adding the y value, right? So we adding the, so let's say f of x equals radical x plus 1. So this plus 1 is basically affecting the f of x, which is affecting the y, but it's not affecting the x function. So what do you think if I want you guys to draw the equations? Let's say radical x. Oh, come on. I have a really bad drawing skill in this class for some reason. I think my skill just bad generally.
Professor, I have a question. I'm sorry to interrupt you. When is going to be the exam?
It should be after we finish up 2, I think.
Okay, thank you.
You're very welcome. All right. Oh, you want 2 exams right now or something like that? It should be like finish the first chapter, and then after that we're gonna play around with some chapter 2, and then I'm gonna give that a third exams for sure. Okay, so
And we do the song like as this word.
yes. So now, what do you think about this curve? F of x equal to radical x minus 3. So what do you think? So we're going to shift the curve. Look at this. Look at this. So f of x minus c, right? When c is positive, we have to shift to the. We have to shift to the
right.
You have to shift to the right, right? You have to shift to the right because it's basically subtracting it. Okay. So a lot of you thinking, why adding the f, then shift up, subtracting the f is going to shift down, but why is subtracting the x, then we have to shift to the right, but adding the x, we're going to shift to the left. Because it's going, so because the reason why we had to shift to the right, because we have to, so let's say with x equal to 3, the entire functions, so when x equal to 3, so the f is going to be 0. So you have to figure out the original point, and then you can definitely going to know whether it's actually shifting. Okay, so it's basically shift to the right 3 units. Okay, makes sense. And now I'm going to rewrite them with different graphs, so I cannot just put it on the same graph. And this is what it looks like. Okay.
I thought it's gonna shift to the left because it's positive.
Yeah,
it's negative.
It's negative, right? So some of you thinking the same way as we shifting the y, but actually you have to think of it opposite for the x, because we're changing the x values. So what's going to make the f equal to 0? So when x equal to 3, that's going to make the f function equal to 0. So if we x equal to -3, so it's going to be starting right there. So it's not working out that way, right? So when x equal to 3, so when x equal to 3, so this is the point where it's going to cross. This is the origin it's going to cross. Okay, and this is when x equal to 3, what happening to the y function is going to, so when you plug in x equal to 3 here, we definitely going to get the y equal to 0. okay? Make sense? And what happening for
When
that
you
is,
plus, it goes left, and when you minus, it goes right.
yeah,
That's weird.
and
Compared to
then,
the other one, when you plus, it goes up. When you minus, it goes down.
right, and then we're going to shift this. So can I use different markers? So I'm going to, that one was a little too intense. So meaning that we're gonna shift the curve, exactly the same curve, but I draw it differently. So unfortunately, it should be exactly the same curve, but I don't know what happened to my drawing skills. Okay, is that good? Is that good, everyone?
Yeah, Prof. So how is the C different from the B?
The C is
That
different,
is-
right? The C different from the B is the fact that, yeah, this is a good question. So this -3 is actually changing the F. It's changing the F. It has nothing to do with the radicand. This has nothing to do with the inside of the X function. However, this -3 is right there is actually changing the X units. You can
X
see that,
unit.
yeah, so the
Okay.
X going to be affected, okay? The X going to be affected before it's changing the Y values. So in this case, we have to combine the X. So when X is equal to 3, so we have to subtract 3 first before we can solve a Y. In this case, X equal to 3, we just do it. And after that, we subtract 3 later on. So this -3 is basically not in the radicand. This -3 is actually in the radicand.
The radicand, okay.
Yes,
So that
yes.
means the radical, all right.
Yeah.
Okay.
So yeah, so this going to affecting the F. This going to affecting the X. Does it make sense? So when it affecting the X, what happens? And then we have to shift the curve either to the left or either to the right.
All
Professor,
right, that makes sense.
Yes, that makes sense.
the number B, 1B, is that -3, and the for C is -3. That's the difference.
So when we come back to original function is radical X. So the X is not changing. The only thing that makes the F changing is the fact that we're going to -3 right there. So this -3 is basically changing the Y values.
So when you say -3, it means -3 because
Yeah.
okay, and then in the C is -3, X -3, not X -3 in the C, correct? This is
Minus,
where I'm confused.
right.
B,
Mhm.
B for me looking, okay, the number 3 in B example looks like a -3, and the C looks like a -3.
So this is still the minus, this is still the subtract right there. So the subtract is still working out for both of them, but only thing that make them different is the fact that this does not carry on the negative, the radical term. This have to carry with the radical term for X, which turns out that it's just changing the X value for part C rather than changing the Y value as part B.
I still see the difference in the two. Because it looks the same, like.
It looks the same. I understand
Yeah,
it.
it looks the same, so that's why I wanted to see what
No,
is the
they are-
difference.
Yeah, but what he's saying is that you see for the C, the -3 is under the radical. It's
Yeah.
under the square root.
Oh, radical, nice. I got it.
Come on.
Oh my goodness.
Oh,
That's the difference. Got it, professor.
Yeah. So that reason why I'm actually, mentioning earlier that we have to be careful.
Oh
with
my
the
God.
radical terms.
Let me take it out the radical on the top of the number 3.
So what about the radical of, what about this guy? What about radical of X plus 1 minus 2? Okay, so that makes more sense. Can somebody help me what to do with this example? X plus 1 is minus 2. What should we do? Anyone?
What was the question?
I'm trying to figure out the graph for the functions f of x equal to radical x plus 1 and minus 2 compared to the original graph that we have right there, which is f of x equal to radical x.
Okay, it moves up. It's not the same.
No, it's not moving up. It's have to.
No, there's inside the radicand there's x plus 1. You made a mistake. You're comparing it to the orange sheet. Orange is just
right.
X in the radicand. It's not the same. It's not even close.
But what I'm saying is that how can we sketch the radical x plus 1 minus 2? So that's going to be the problem.
It went down 2. On the y line, it went down.
Right. So it's have to go down 2, right?
Yeah.
And what about the x?
The x, what am I comparing it to?
The x is.
I don't have something original. If you give me original,
no, the original is here. The original is radical x right there.
Oh.
So we have to shift.
Okay, so it went left because it's a plus 1.
Right. So first we have to shift down 2 units, and then you have to shift to the left 1 unit. Are we good?
Oh, you can have 2 inside 1. You can have 2 changes. 2
shifts
in 1.
No, we can have 5 changes. We can have 20 changes depending on how we're going to look at it. Okay. So
2 changes, 2 shifts inside 1 equation.
Right. We can have we can do 5 shifts later on after we finish this. Okay. But so far so good, correct? So far so good, right? Any concern about this guy? Any question?
I got it.
We need to find.
Professor, I have a question.
Yes, you have questions.
So when there's a positive under the radical, we will move the opposite direction, and there's a negative under the radical, then we move the opposite direction on the x line, correct?
Yes, on the x line only, but for the y, we still hold the same thing. So when it's subtract,
no, correct.
Yeah, when we subtract, you have to shift down. When it's add, we have to shift up.
All right, thank you, Professor.
You're very welcome. So now, do you believe that the curve should go what? So we have to go down 2 units, right? It's have to go down 2 units, so that would be -2, correct?
Yeah, and then we go to the left. 1 unit to the left.
And it's gonna go 1 unit to the left, so it's had to be -1s right there. Okay, is that good? So the intersection point is right there. Are we good?
In the middle.
Yes.
And in the middle, so we have to, and then this is what the curve looks like. Am I doing too fast, or are we good to go?
Hold on.
We shift 2 down. I know 2 is not appropriate to -1s here because the gap with -1 is actually a little smaller, and it should be around here. So we shift down 2 and then shift to the left 1. So this is what the curve looks like compared to the original curve. All right, so now should we move up to the next questions?
Professor, excuse me. Why in this case -1?
I'm sorry?
X plus 1.
Plus, so you're gonna see that plus, then we have to shift to the left. When it's subtract, then we have to shift to the right for x.
Okay.
So the easiest way that we can make it look better is that when x equal to -1s, right? So when x equal to -1s, so the entire thing gonna be 0. So x -1, that the curve will be almost 0, but we have to go down 2 because we have -2 right there. All right, so are we good?
Yes.
Yes, Professor.
All right, so do you like the refraction curve? Let me just show you guys what it is. All right, reflections around the x and the y axis, okay? So before we start, so we're going to have this, hold on a second. Okay. All right, reflection around the x-axis. So when we have a negative, so you see that when we have a negative sign in the front of the f of x, okay, so we have it. So what happening? Okay, so if changing, so it's actually outside of this, okay, outside of it, of the f. So it doesn't affect the x, okay. So if it doesn't affect the x, so we have to think of it counterintuitively, such that this will be reflecting around the x-axis. Okay, it's going to reflecting around the x-axis. When the negative side inside the x, okay, so we're going to reflecting around the y-axis.
Hello,
okay.
your meeting just disconnected and reconnected. Was that my end or was that your end?
I'm not sure, but I think I'm still talking. Any interruption?
Okay, what did you say? Because I might have missed it.
Okay,
What did you say?
so what I said right there is that when we have this negative sign in front of the f of x function, it's going to shape the curve around the x-axis, right? Around the x-axis. Okay, so we have to be careful with this. Okay, around the x.
So it's symmetric over the x-axis.
Yes. So whenever we have a negative sign in front of the f, it's not inside the x. When we have a negative sign inside the x, what's happening is going to be reflecting around the y-axis. So this is what we have to be careful with. Okay. So now, what do? I'm going
It
to
happened
get you.
again. I left by accident. I don't know. Maybe it's the Zoom. I'm
Okay.
playing with Zoom. My fault.
Okay.
You said what? You said when it happens, it reflects over the x-axis.
When we have a negative sign in front of, when we have a negative sign in the x, and it's going to be reflecting around the y-axis. Okay, so this is the thing that we gotta be careful with. All right, so I believe it's gonna be the things that we are looking for. So now we are working out with a certain values. I believe it's a very important values that we're going to look through. Okay, so let's take a look at examples. So let's be just example 1E. Okay, so just want to make sure that we are still be using the same function that we use. But now I want you guys to sketch the function f of x equal to negative radical x. Is that cool? Does it make sense? So what do you think? How can we sketch the functions f of x equal to radical x here? Anyone?
It's gonna be reflecting the. So sorry. Okay, it's gonna reflect the y-axis.
Very, very good. So no, x-axis. Have you so because the negative side is not affecting the x, so it has to be with symmetric around the x-axis.
Yeah.
Okay, so you have to think of it
Sorry.
counterintuitively. So this is what we have for the original curve, right? So this is f of x equal to radical x. So we're gonna keep that curve the same. Okay, we're gonna keep that curve the same. But now I'm going to shift the curve. I'm going to reflect, right? So reflect around the x-axis. Okay, so what the curve looks like is so this is what we have for the x-axis, right? So this is what we have for the x. So we have to shift, we have to flip them on the horizontal lines on the horizontal x-axis. So this is what it looks like. Are we good?
Yes.
Yes.
Any concern, any questions? What about, I'm going to give you guys one example. So 1f. I'm going to give the functions f of x equal to It's radical negative x. What do you think? So it will be anyone?
Y-axis.
It's going to be reflecting around the y-axis. Okay. All right, so this is what we have for the original function. Okay, so this is what it looks like. Is that good, everyone? Am I doing too fast for this, or you good to go?
Sometimes, yes, Professor.
Okay, so now I'm going to ask you guys to I want to figure out what it is. Negative, okay? So negative, so we gotta be careful. Negative of radical negative x. Right, what do you think? What do you think of this curve? Does it make sense? So we have.
That's confused. That's gonna be different ways, like going down to the curve and up at the same time. Wait.
No. What I'm doing here is that I'm going to shift the so first we have to shift the curve, right? We have to shift the curve with.
That is confusing.
No, but we know the fact that if we have a negative side in front of it, right? So we have to reflect the curve around the x-axis. When we
It's gonna
have
end up in the third quadrant.
yes, very good.
believe.
So when we have with the negative side inside of the x, so it will be reflect around
Y
the axis. So in this case, when we have a two negative sign in front of it, so it will be reflecting around x and y axis on both axes, and it have to be end up in the third quadrants that we have earlier. And so this is what it looks like. Okay, so let me just draw the graph real quick. So you feel like this is the end of the curve. What happened if I'm going to give you like negative radical negative x plus 5, and then after that I close parentheses and we have -2. It can't just shoot like going forward and backward. And sometimes you can also have the shrink and also the scratch of the curve as well. So we can learn that later. But we can definitely go into it would definitely go into looks like this. Okay, so the curve, the shape for the curve, it will be shifting from the original one. So that's going to be like this, right? And then it's going to shift like that. Are we good? Are we good for that?
Yeah, that's what I
Yes.
thought. One's going up and the other one going down.
Yeah,
Right.
that's what I was saying. The third quadrant.
But
That's like an inverse, right?
I mean,
that's like a diagonal reflection, a diagonal symmetric reflection or something like that.
The inverse for radical x will be the x squared when we talk about the positive for that. But it's
like
yeah.
It's like because there used to be another one that says x equals y mirror, but this one is like a negative x equals y.
If two functions are inverse, if and only if they are symmetrical around y equal to x. Yeah, so we're going to get to that because we want to know about the curve transformation, but we're definitely going to come back to the inverse functions and how we're going to solve the inverse function and how we're going to look for composite functions later on. Okay, so.
But is that an inverse or not? I don't think it's inverse.
Don't go away. Don't put away, Professor.
I'm sorry.
Right?
Don't put away. I'm taking notes. Give me a second. Don't delete it.
Yeah. Hold on a second. So let me just, I can't hear because two people talking at the same time. So
sorry.
Yeah, that's fine. Yes. So what do you ask? I apologize for that. So yes.
Me,
Yes. So you just asked me the question before.
I said, is it an inverse? Because when I think about an inverse, I think about inverse is like the opposite. It's not always, and it usually looks symmetric.
Yeah. It
Question
it
is,
would
where is
be
the line
yes.
that is symmetric over? Because now I'm thinking, is the line that is symmetric over, it cannot be x equals to y, because x equals to y is like a diagonal line that the top is facing
Mhm,
right and the bottom is
mhm.
facing left. So it has to be like a negative x equals to positive y, reverse it, and make the line be, I'm
The inverse,
assuming,
right?
the top leaning,
Uh-huh.
the top leaning right, left, and the bottom leaning right. So that would be the mirror of what this is, I'm guessing.
So
No,
you
it's not.
think you think
It
it's
still
you?
won't. I'm wrong. I'm wrong. I'm still
It's,
wrong.
no,
Nah, I'm
it's
still
not
wrong.
actually it's not actually the mirror for y equal
Yeah,
to
it
x.
cannot be.
Yeah,
That's
cannot.
x equals to y,
Yeah.
right?
Yeah, so x
Because
equal
then
to
the,
y is actually the line that we're looking for the mirror of these two functions. But again, you're actually talking a
but what
little bit
about
too
negative x
early.
equals to y? What about that mirror? What about that line?
Uh,
Negative x equals to be the opposite way.
it's
Yeah,
actually
exactly.
yeah
Still not. Still not.
that one's look a lot better, but it's actually there's no justification for the inverse function looking this way or that. But this is actually this is what looks it have to be on that side. But generally, the inverse function for radical x is usually have to be x squared. But we definitely going to talk about that later on, but this is not now because we're going too early. But you actually on the same track that the way that we the way that you mentioned it, but it's
So
definitely
both my assumptions to check was wrong. Well, I'm glad I checked.
yeah. But
In my mind,
anyhow,
yeah,
yeah. So anyhow, so we're going to so are we
Professor,
good
I
with
have a
this?
question.
Yes.
Okay, so my question is that the function, it goes around, it rotates.
Uh-huh. Mm-hmm.
That's what it does.
Yes, that's what it is. And
Okay,
it's actually flipped. So in other words, so you can either shape the x-axis, so you can shape the function down first, and then you shape to the left. So this is what it looks like. Or you can shape around the y-axis, so you're gonna shape up, you're gonna shape to the left, and then you're gonna shape down. So you're gonna get this one for sure. You can do either way for that. But you have to reflect these functions around the x and the y-axis. Okay.
Okay, I have a question, another question. Okay, so if it's the function is in the second quarantine, it goes to the fourth.
Which one?
If it's like this, like if the thing is on the first, right? It has to go to the fourth, or can it go to the third?
The first functions have to go to the 4 because we only reflect the functions around the x-axis. But for example, 1e, because we won't have a negative sign in front of the x, in front of the radicand, I'm sorry. But if you have the negative sign in front of the x, so we have to be going to the second quadrant where it will be reflecting around the y-axis. However, if we have two negative side, one in the front of the radicand, one inside of x, so we have to do both. It's have to be reflecting on the either, so we have to reflect that functions around the y-axis, and then you're gonna reflecting around the x-axis later on. Or we can do it for the x first and then for the y later on. So it's definitely going to make sense.
She is right to say it
Okay,
looks
thank
like
you.
You're right to say it looks like it's rotating, because it's like you went from quadrant 1 to quadrant 2 to quadrant 3.
Yeah.
Vice versa, quadrant 1 to quadrant 4 to quadrant 3.
We can go from the first one, and then we reflect the x and then we reflect the y. Or we can go from quadrant 1 and then we reflect the y first, and then we reflect the x later on. So we still end up getting a same curve for sure. No matter how we're gonna play around with that symmetrical models. Okay.
Okay. My question is, so when it's two negative, you skip one quadrant and you go to the other one?
Okay, you have to be. It's actually the thing that we have right there. Okay. So are we good with this section? Is that too much for us? Playing the transformation is nice because it's basically empower the imagination, and it's really cool. Not only that, as we going to learn about the sketch and the shrink, okay, of the function. It's somehow not gonna be easy to look at it, but it's generally very important to know what it is, the sketch and the shrink of the function. Yeah, so this is what it looks like. So what happening for that is when the c is greater than 1, it's going to make, okay, let me just write them down real quick. So when c is greater than 1, okay, so let's say c is 2, 3, 4, it's going to make my functions a lot skinnier because the y value going to be bigger, okay? So it's gonna make the functions going up faster, okay? Make the function is greater than 1. So it makes the functions skinnier, more skinnier. Okay. And for the functions c is less than 1, right? So let's say we're going to use 1/2, 1/3, like a fraction, and it's going to mix the functions a little fatter, okay? All right, so it seemed to be a little bit tough, okay? But we definitely going to take a few examples and see how it looks like. So I'm going to go for example 1h. Okay, 1h. So what do you think about this function? So instead of we have this, so but now we're going to have 3's radical of x. What do you think? Anyone?
That's interesting. It amplifies and it gets bigger,
Yes.
dilates or smaller.
The
I think it gets
amplitude,
bigger.
yes. It's
What do you
gonna
call
be
that grammar you use? Magnitude? What do you say?
yeah, so amplitudes for that.
Amplitude,
Yeah,
amplify. That's a
amplitudes,
word.
yeah.
Oh, okay. Interesting.
Yeah, this is something like that we have right here. Yeah. So we're gonna make it like 3 times bigger, right? Because it's going to make that functions a little bigger for for the y value. So in other words, we're going to have the original function. So this is what it looks like for y equal to radical value of x. So this is y equal to radical value of x, right? And what about the 3 times of that functions? So it's going to be something that exploded 3 times. Okay, so this one, we're going to have y equal to 3 radical x. Is that good, everyone? Are we
So
good
it's
for
gonna
that?
become fatter. It's gonna become fatter.
No, it's gonna be taller. It's gonna be a little more skinny. Sometimes, in other words, it's gonna be a little more taller because the value, because we keep the same value of x, but now the value for y increases 3 times, right? So if for the same value of x compared to the original function, the value for y actually bigger, like 3 times bigger. So it become a little
more.
Yeah, it's
more than 1.
Yes, it's more than 1.
Thank you.
C
I'm
is more
sorry.
than 1 for that. Okay, because the amplitude that we have is 3. So in this case, that's going to make my function looks a lot taller, look a lot more skinny compared to y equal to radical x. Make sense?
Yes.
So how do you plot this? I see the imagery on the graph, but what does the numbers look like, x and y axis? What do they look like?
Which one? The
Because there's a correlation of for every x, the the square root is equals y.
right.
So
So,
this
but
one is what? For every x, the square root of it times 3.
yeah, it's just
Huh.
times 3 times. So let's say we're gonna get x equal to 1. So the original graph is gonna get y equal to 1, but the function that we have is y equal to 3. When x equal to 2, the original graph should be y equal to radical 2, but the graph that we have here is 3 radical 2, so that's gonna be a lot different, 3 times different for the y values.
Let's use
Because
perfect squares. I think it'd be easier that way. So
yeah,
1 square root of 1 for the blue line, square root of 1 equals 1. Square root of 4, if x equals 4, that's 2,
yeah.
y equals 2. If x equals 9, that y equals
Mhm.
3. But
So
the
if
other
you
red
can
line,
actually do that as well. So for when you plug in some perfect square value, so let's say when x equal to 4, the y will be equal to 2. But in this case, when x equal to 4, the y equal to 6. So that would be 3 times bigger, doubling the values for that. Okay. So what about the f of x equal to 1/4 of radical x? What do you think?
It's gonna become more flattened.
Yes, so it's going to be a little bit.
shrink. You're going to shrink. You're going to get smaller.
Yeah, it's gonna make the y value smaller for that, and just the way that we have right there. So you're going to shrink vertically. Vertically will be around the y-axis, okay? And so this is what it looks like. Can I just do it on the same graph? I
All
feel like
about
it's,
the multiplication, which is
yeah.
actually a division because it's a fraction.
So can I just do it on a single graph right there? So it
Yeah,
just,
yeah, you can. Different colors.
yeah, so that one is actually y equal to 1/4 of radical of x. So in other words, just put it radical x over 4. So I feel like it's easier. Okay, is that good, everyone?
Yes.
But how we do we have the horizontal scratch and change? So let's say we're going to put it down like y equal to f of cx. Okay, so the c actually come with the x. So instead of I'm asking you to get a function f of x equal to 3 radical x, what about radical 3x? Okay, so it's gonna feel like slightly different, but I think we're going to skip that because I don't want to give you like a lot of information, but I think I stop at the vertical shanks, and and then um, and then we're going to play well with them. We do have the horizontal shank and so on and so forth, but we're not going to spend too much time working on it. But we're definitely going to look through one example and see what it looks like. Okay, so so given the graph like this, and then I want to sketch the graph and what it looks like, okay, on a model coming from that example. All right, so let's play around with this and see how it looks like. All right, so now how can I sketch the graph f of x plus? I think I did it. I just shifted the curve 1 unit, correct? I shift the curve 1 unit. Is that good? So indicating by the curve f of x plus 1, so I shift the curve 1 unit. Okay, and what about y equal to f of x minus 1? So what do you think? So we have to shift. So this,
Yes, you have to shift.
yeah, so we have to shift the curve up and down. I think I'm missing the word ups right there. Shift down the curve 1 unit, correct? So it's generally, so we have to go down right there. So I'm not going to sketch this one because I don't really have the ability to sketch well, to be honest. And so what about, so this is shift up the curve 1 unit. And what about the curve f of x minus 1? What do you think? What should we shift there?
Or down to the left.
Shift it to the right.
Very good.
the
We
right.
shift to the right. We
To the
shift
right, but it's not going, not down.
not down
to the right.
because minus
First
1 is
Okay.
coming
Opposite.
with the x. Minus 1 is coming with the x. Even if so, we have minus 1. We're not going to shift to the left. You have to think of it for the x value. So we have to shift to the right. The curve 1 unit. And what about the y equal to? I'm gonna. So we know the fact that f of x plus 1 you're gonna shift left. So what about f of negative x? What do you think?
That shifts to the left.
No. F of so the negative side basically come with the x
A
value.
mirror, a symmetric on the opposite side of y.
So we have to be symmetrical around the y-axis, right? So reflect around the
Because you're
y-axis.
negating the x. So if it was positive, we turn it to negative. If it was negative, we turn it to positive. So it's flipping over the y.
So what's going on for that is, so how it looks like, how the curve looks like when it reflecting around the y-axis. So it should be going like this, right? But I don't have a good drawing skill. Oh, come on, this something like that. Okay.
Now that looks confusing. You
Oh.
sure it's not symmetric? You made it look like you just
Yeah. It should be. So you can actually flipping this guy first, right? You can shifting this guy first, and then you can shifting this guy later on. So I feel like it's easier that we can see them on the x and y axis. Okay. Are we good? Is that good, everyone?
Yeah, that makes sense
I
because
have
the
a
whole blue
question.
line. Yeah, that makes sense.
Yes.
I have a question. So when it's next to the x, the negative x letter, you had to rotate it.
Yes, you have to rotate them around the. So when you have the negative sign in front of the x, so we have to rotate them around the y-axis. When we have a negative sign in front of the f, okay. So in this one we have to be rotating around the. Around what? We have a negative sign. We have negative sign in
The
front of.
x-axis, the opposite.
Axis.
The x-axis, because it's the y that is being flipped.
Uh-huh.
So
But
that's
remember,
over the
if we're flipping around the x-axis, it's going to end up the same thing because this function is actually even. Okay, so with the even functions, usually going to have the same flip for the x and the y axis. I will let you know what it is when it comes to the next part of the chapter. But we basically good to know what it is, right? So reflecting around the x-axis.
That sounds confusing. It says it's still even. What are we talking about by even?
The even functions and the odd functions, so they have a certain characteristics. Okay, so we haven't really mentioned it, but we're definitely going to go toward to that after we finish the curve transformation. So we have to deal with the odd and even function, and then we have to do the inverse function. We can finish chapter 1. So chapter 1 is a very long chapter, so it's very tiring because I basically make them as a single chapter. And after chapter 2, we're going to have further exams. Okay. So what about the y equal to?
I have a question, but I don't want to interrupt you. Let me
Yeah.
know when you're done. I could ask now.
Yes.
Okay. I'm still stuck on that even because when I think about even, I think about the y value coming out even after
No.
you input it to x.
So yeah. So I mean, even if when we change the x from negative to positive, the y value is going to stay the same. So this is what we call the even function. But we're going to get back to you. I'm going to get back to you next class when we have a chance to talk about the even functions and then the odd function. Okay, so we're definitely going to do that for sure. But we're still a little ahead of what we have right there. So now we're going to have the y equal to f of negative x. So what do we think? So it will be reflect around
y and x oasis.
Okay.
All
right.
Don't delete it, Professor. Don't raise it, please.
Yeah. Are we good? Is that good, everyone? Does it make sense for us, or?
Yes, it does.
It does, right? But once you know it better, we're gonna try one example and see what's going on. Okay.
Professor, can you grab the last one? The negative f, negative x.
Because this function's even functions is going to be the same graph as the y-axis or the x-axis, so it's always stay the same right there. It's still be the same because it's going to be like this for sure. Okay. And some graph that we were reflecting about x and the y-axis is going to go back to the original graph, and I will let you know for certain things, but on the exam, so I know it's not gonna be easy to graph. The most important thing is we're going to state what the most important what the graph looks like, and you don't have to graph like it's shifting up 1 unit, so you're not gonna put the things right there. Just write them down, shift up 1 unit, and -1 shift down 1 unit, and x minus. So you don't have to graph like this, like shift to the right and something like that. And I feel like it's rather confusing for the shifting, because remember that this one is actually this is actually a curve that is the odd function. So when it comes thing like that, odd and even function. So when you have something like that, it's just definitely not going to be easy to graph them. But I'm going to give you one example. So you will going to tell me what it looks like, and then I'm going to scrap it for you. Okay. Since I'm running out of time, so I'm going to go over that example real quick. Okay. So remember, I always let people out a little early because I believe we deserve it. We don't take a break. We don't have any, time for that. And I usually come a little early, so I apologize for that. And for those of you who come maybe a little bit late, so you can read the recording, but it's definitely just something that I introduce people and then I ask about the homework problem and so on and so forth. So now I'm going to do one example, or maybe two examples, and then I will let you go for this. Okay. And then after that, we're going to talk about the even and odd functions. Examples 2. Okay. 3. So given by the graph y equal to f of x equal to x squared. Okay. Let me just put it down here. Uh, 10 minutes late. You are in a big late right there. But I understand sometimes it's Monday. It's not easy to wake up. Maybe you have another class coming on, or maybe you have to take care of family members. That happens. All right. So I want to graph, right? So sketch the functions g of x equal to 3x minus 1 square. Okay, plus 2. All right, so what do you think? Anyone?
I think it's gonna go down 3 times, and it's gonna shift 2 times to the left.
No, yeah, so that is actually a good points, but really the first thing that we have to remember, we have to look at the starting point. So okay, so what the function looks like. So this is what the function. This is what the functions for y equal to x squared. Okay, so it's this is an even function. It will be symmetrical around the y-axis. So all right, so hold on a second. Okay, so this is what the functions y equal to x squared. And now what I want to do is that I want to sketch it. So before I can sketch this one, I want to know if there is any way that I can write them down, how we're going to ship this. So we have to ship what? So try to ship the y first, okay?
It's gonna be 3 negatives down.
So you're going to ship down 2 units, correct?
No, it isn't down.
No,
Isn't it the negative 3?
The negative 3 has nothing to do with the g of x. The negative 3 is just coming with the x minus 1 square. It has nothing to do with plus 2.
I'm confused now.
Okay, so the most important part when you see the problem is that we're going to, so the panda is basically telling us to do the parentheses and you know, and then exponents and multiplication and division, and then after that addition and subtractions. But when you do the shift, you try to do backward. So we try to shift the y first. Okay, so the y, so this is plus 2 is definitely has nothing to do with minus 3. Do we agree? Because the minus 3 just go with x minus 1 square. Are we good?
Okay, I got it. So it's the last number always.
Right. And then we always try to shift with the y.
Sorry, I have to pay attention. What is going on? What are we doing?
So we're trying to sketch the curve given by the original graph, which is y equal to x squared. And for that function, so we have to shift down 2 units. So we have to shift the y first, right? Shift down the first. So we try to shift it down and shift to the left before we take care of the other things.
So we shift to the right because it's a minus 1.
No, plus.
Then
no.
we square it.
Yeah.
We shift to the right because it's a minus 1. I mean horizontally. Then we shrink it because it's a minus 3 multiplication.
So
it's and then we.
But we have to no. But we have to shift down first. So we have to shift down 2 units. So that's going to make this.
Why are we shifting down? It says plus 2. Shouldn't
it's not up? Not supposed to be up?
It says plus 2. It's up.
No, the 2.
Oh, up. Yeah. Yeah, I'm sorry. I have some writing right there. So yes, hold on a second. So it should be
confused about like.
Yeah, it should be.
I'm sorry, I was confused.
Yeah, that's what I was looking at. Like, I'm like,
you know, I have some writings right there. Hold on a second.
I'm looking at my notes and I say, wait, no, no.
You know, last minutes, come on, you gotta give me some excuse for that, right? So we have to ship up 2 units, correct? And you have to take care of 2 first. So we have to take care of this guy. And then we have to ship to the right 1 units because we have to take care of minus 1. And now what else do we have to do?
So are we working from right to left? That's how you do it?
Yeah, so we have to do the right to the left first. And then after that, we go in to consider the negative terms. So what about the negative terms?
Negative is
multiplied by negative 3. So does that mean how do you multiply a negative? What is that? What happens? multiply times -3, because if you multiply a +3, it amplifies. It
No,
becomes
no, no, no.
bigger.
I know. It's gonna be like, it's gonna make it the curve a little bit more skinny, but we have a negative sign in front of it, in front of the x minus 1 square, right? So we have to reflect, we have to
Symmetry.
To the X
It reflects
Rowdy.
over the
axis.
y. It reflects over the x or the y.
X.
x-axis, okay?
It's the X axis, exactly.
Right? Yes, that's correct. You're absolutely
Mhm.
correct. So it will be reflecting around the x-axis
Oh,
because
because
it's
it's
The
changing.
negative is the
Yeah.
front. The negative signs is in the front.
That's correct. So finally, what we have right there. So what
Okay,
does that
what
mean
she
by
just said in the front, when something's in the front, it is reflecting over the x because it's multiplying into the y.
no, because we have a negative sign in front of us right there. So we have a negative sign right there. It's not inside the x, so we have to be careful. Okay.
Okay, when it's outside, it is reflecting over the x because it's multiplying the y. But when it's inside, it's
So we're
changing the
reflecting the
x, so
y.
it's reflecting over the y.
All right.
That's
So
incredible.
now we're going to have the last one. We 3. What does that mean by 3? So the C is 3. So what does that mean? So we will be
Amplified 3 or shrink 3.
sketch. Yeah, sketch by 3. Okay.
What does sketch mean? Shrink or amplify? What is that?
The shrink is actually going to be like this. This is what we call the shrink by the factor of 1/c. So it's going to make the function more flattening. So the scratches basically make it vertically and make it going crazy, going up a little bit faster for this. Okay, so now
skinny, Professor, right?
yeah. So now I'm going to sketch the functions and then I will let you go. Okay.
I mean, that example you gave, you said that when it's something you multiply by a fraction, a positive fraction, which is basically division, the curve gets wider.
Yes. So yes. So this one gonna make it looks more skinnier, for sure.
It's a negative.
No, it's not about. It's about the amplitude that we have. The negative just basically means that we have to reflect around the x-axis. Okay.
Okay, the negative is taken care of. The 3, yeah, because I'm confused. Like, okay, the negative is taken care of, but the 3 means that it shrinks. Or if it's a fraction, it gets wider.
Right. So now we're going to sketch the curve.
I have a question.
Yes.
So 3 is the thing that makes everything wide. So you don't have to shift anything with 3.
The 3, we're going to shift it later on, but we need to take care of the going up 2 units, correct? So this is a things, right? And going down, we're going to the right 1 unit. So this is the thing that we're going to put us here. Are we good? And this is going to be the curve loaf side, right? Does it make sense? Now it's symmetrical.
Yeah, sort of.
Now it's symmetrical around the x-axis. So it's going to be like this. Correct? Something like that. Right? Right? And then it's going to be 3 times bigger. So meaning that it's going to be something that we lose. It's going to be something that we have right there. It's going to make it look so skinny.
Yeah.
Does it make sense?
Did I miss something? You shift up 2 units. The middle, the axis of symmetry, that's what you call it, right? The invisible line that divides it and makes it symmetric. The axis of symmetry is literally on the 0, x equals to 0, and y is on the y-axis, right? How did we leave the axis of symmetry, leave the y-axis in the first quadrant, the orange parabola? No, it shifted up 2 units, right? Shift right 1 unit. Oh, that's the one, right? That's the one, right?
Yeah, so shift to the right 1 units right there. So shift up 2's right here. So and then now after that, I'm going to take the symmetric. All right, so that's pretty much it. And I'm going to see you guys on Wednesday, and then we have the homework posted. I hope you guys are going to enjoy your date And that's pretty much it. And I will see you guys on Monday. I'm sorry, on Wednesday. Okay. So you have more concern, just email me as well regarding either the homework problems or the Zoom things. Okay. So
Professor, do you mind going back to where you were at, or you just deleted it? Yeah.
yes.
I'm drawing the graph. Just give me a second.
Okay.